Bismillah. Bismillahirrahmanirrahim. This is our third lecture, and we were talking about the integral transform. During last two lectures, we have talked about the Fourier transforms. We have solved some problem on that, and then I have given you an assignment to solve some problems. Now today is about the Laplace transform, because this Laplace transform method is very extensively used in solving differential equation. Now Laplace transform we have already defined of a function ft is represented by this symbol, and it is defined as by this equation. Now look, ft function has been transformed. This has been transformed with the help of this to a new function f alpha. Now t greater than 0 means t should be positive, otherwise this thing will become plus, and that is not the required transform then. Okay, it won't be with plus sign. It is not Laplace transform. It is negative sign. It is the helping function. Okay, so it should be in this relation. The integral should exist. It means that integral shouldn't be 0. It shouldn't be infinity, but it should have some value. Now, since we have transformed ft into f alpha, we can go back. You can take inverse transform of this f alpha. This is inverse transform or Laplace transform of this. You can go back to ft. So Laplace transform of a function ft is this, and its inverse Laplace transform is back ft. The linear transform, the Laplace transform is a linear operation. Why? Because it is a into one function plus b into second function. You are going to find the combined transform of that. No problem. You can find their individual transforms and then add the result. You will get the answer. Or you can add the two and find it, or you find separate Laplace transform and add them. You get the same answer. This is known as the linearity of operation. Then there are some basic functions for which we are going to find the Laplace transform. First is ft is equal to 1, and t should be greater than 0. Now Laplace transform of 1 is you put for ft 1, and you have to integrate e raised to minus alpha t. Yes, we have integrated e raised to minus alpha t. It is e raised to minus alpha t divided by minus alpha. This is just simple integral, 0 to infinity. If you put the limits, then you get 1 over alpha, because limit substitution is simple. You can do it on your own. So Laplace transform of ft, when ft is 1, answer is 1 over alpha. Answer is 1 over alpha. This is first case. Second case is if ft is an exponential function of t multiplied by a constant k. So Laplace transform of e raised per kt is equal to 0 to infinity, and for ft I am putting e raised per kt because it is given. E raised per minus alpha t is already in the transform. Integrate it. Look, this and this can be combined together. T is common, minus is common. You have alpha minus k. Integrate it. This divide by that. Substitute the limit, and you get 1 over very large thing is 0. E raised to 0 is 1, and this minus minus become big plus. So your answer is 1 over 1 alpha minus k. So that is the second result. That is, what is the Laplace transform of a exponential function with multiplicative constant plus k. Now similarly, this could be with minus sign, and if you do this, then only this thing changes. This is 1 over alpha plus k. It's simple. Then what happens if ft is cosine kt? So let's find Laplace transform of cosine kt. I have changed cosine kt into exponential function e raised to I kt plus e raised to minus I kt over 2 or 1 over 2 common. So this is linear combination L of this plus L of that 1 over 2. Now you know what is the Laplace transform of a complex function, and this is with plus sign, and so you will be using this. So it is 1 over alpha minus ik, and this is for that because for k I have replaced ik e raised to minus ikt, and answer is 1 over alpha plus ik. This is with the help of this. Then next thing is simple. 1 over 2 is common. Take LCM, simplify that, and Laplace transform of cosine kt is alpha over alpha square plus k square. Alpha square plus k square. Similarly, if you want to find ft is equal to sine kt, look here, you will get this answer. I haven't calculated it, but this process is similar. The only thing is here you will have e raised to ikt minus e raised to minus ikt over 2i, and then do the similar procedure and you get k over alpha square plus k square. And this is when you are having here t raised to n, and one thing more, alpha should be greater than 0, n should be greater than minus 1. Why alpha should be greater than 0? Because this thing should not be, there shouldn't be denominator, it shouldn't be equal to 0, so that this become infinite. It should be finite. Alpha shouldn't be equal to minus 1. Okay, it should be greater than minus 1. Okay, so it can be 0, but it cannot be minus 1. If it is minus 1, then alpha raised for 0 is 1. But if it is minus 2, then it is alpha divided by alpha. So ft is equal to Laplace transform of t raised to n, where ft is t raised to n, and its answer is n factorial or alpha n plus 1, and t should be greater than 0 and greater than minus 1. So you have a kind of table. You have a kind of table which is there, and if you want to see in the book, this table is given for 8 function. Okay, I have done it for 6 function, but they have given it for hyperbolic function as well, and then there is its use. So please go to chapter 4, page number 98 of Advanced Mathematics, Shyam series book, and you will find it. Okay, and then there are some solved problems. Problem 4.4a. This says Laplace transform of cosine omega t. I have taken kt, in the book it is omega t, so it is the same problem which I have done there. Then Laplace transform of sine omega t, that is its b part, and that is also solved. So solve problem 4.4, it gives you these number 4 and number 5. Okay, proof of number 4 and 5. 4 I have done it, 5 is in the book, so you can consult the book and you can find that thing there. Okay, so similarly you can find other transforms if you read the book. For example, some theorems are also given on page 101. You can study that and you can get some idea. Now let's see how you can apply the knowledge of transform of these basic function, that is when ft is 1, ft is e raised to kt, minus kt, cosine kt, sine kt, t raised to 1. So these are few problems. This is solved problem 4.5, page 104, advanced mathematics. It is solved, and it says find Laplace transform of each of the following. First is 3 raised to power minus 4t. So you will find Laplace transform of this. 3 is out. So you will be having Laplace transform of e raised to power minus 4t. And this minus 4t is like this. That is k is minus 4. And when k is minus 4, you will substitute there. So look, e raised to power this, 3 out. And this Laplace transform is alpha minus, also it will become alpha plus 4. Okay, so that is there, and it says alpha should be greater than minus 4. If it is minus 4, then what will happen? Then this will be 0 and this will be not defined. So this is why it says that it is greater than minus 4. The second problem is Laplace transform of 2t square. Okay, 2l t square. Now look, put n is equal to 2 here, you will get the answer. This 2 is outside because this is constant. So this 2 is outside, and result will be n factorial 2 factorial alpha n plus 1, 2 plus 1, which is 3. So it is 2 into 2 factorial alpha cube, 4 over alpha cube, and alpha should be greater than 0, positive, because if it is 0, then what will happen? This will not be defined, and this is by 4, okay, sorry, by 6, this one. Then is 4 cosine 5t, 4 cosine 5t, and look, cosine omega t, omega is 5, so it is 5 square here, so 4 alpha divided by alpha square plus omega square or k square, so it is 4 alpha over alpha square, and that is by, this is number 4. Then is D, Laplace transform of sine pi t and sine kt. So where is k? Put pi square, so that is there, and alpha should be greater than 0. Again, okay, shouldn't be 0, because ye pi cancel ho jayega and you will get a strange answer. Alpha minus 3 square root of t minus 3 t raised to minus 1 over 2, so your n is minus 1 over 2, minus 3 as it is, minus 1 over 2 factorial, alpha minus 1 over 2 plus 1, minus 3, minus 1 over 2 factorial, divided by alpha 1 over 2. So these are, this is solved problem 4.5. Now, you should try solve problem 4.6, and you can also try unsolved problem 4.64 and 4.65, page 118. Page 118, and you can also solve unsolved problem 4.48 on page 117. Okay, do few of them for your own practice, and you will get the answer. You will get the answer. Now, that is one thing to do. Now, let's now move a little bit more further. Having done with this elementary job, let's move further. How to find the inverse transform of a function. कि भाई अब उसकी Laplace transform तो मालूम कर ली है, how you can find the inverse transform of a function. Okay, for that purpose I'll ask you to go through problem 4.12. Solve problem 4.12. Now see what it says. Okay, this is solve problem 4.12. This is on inverse transform. 4.12, page 106. It says find Laplace inverse of 5 over s plus 2. This is A. B is Laplace transform of 4s minus 3 over s square plus 4. D. C. Laplace transform, Laplace inverse transform of 2s minus 5 over s square. D. Laplace transform of 1 over sk, 1 over s raised to the power k. Now here, you know, this table will help you to find, to solve the problem. Look at A. A is a Laplace transform of 5 over s plus 2. This is s. He is using symbol s, whereas I have used symbol alpha. Okay? So don't worry, s is same as we have used alpha. As before, 5 can be taken out. L inverse 1 over s plus 2, 5. Now look, which one suits there? देखिए, alpha is s, k is 2. Alpha is s, k is 2. So what you will get? E raised to the power minus k की जगह 2t. So that is the answer. 5 e raised per minus 2t is the answer. That is with the help of the table. Similarly, B portion. B portion says Laplace transform of 4s minus 3 over s square plus 4. Look, this thing can be written as 4s over s square plus 4 minus 3 over s square plus 4, and this will be equal to 4 out, 4 L inverse s over s square plus 4 minus Laplace of this 3 out, Laplace inverse of 1 over s square plus 4. Okay, 1 over s square plus 4, and let me check it. This is 3 4s over this. Okay. Now what I am going to do, as far as this is concerned, no problem. Look, this is that expression, okay, inverse of that. If you take inverse of this, you will get sine kt, okay. If I take a L inverse L, sine of kt, it will be L inverse k over alpha square plus k square, and these two cancel, so sine kt is inverse of that. Now look, what is happening here, it is equal to 4 cosine 2t, 4 cosine 2t, because this is 2 square. This is alpha square, and that is 2 square, and that is, look at the cosine expression, that is by 4. Okay, problem is there, if you have 2 there, no problem, but 2 is not there. So what we are going to do, we are going to divide by 2 and multiply by 2, and that is s square plus 4, and this will give you 4 cosine 2t minus 3 by 2, and look there again, it is again the same thing, okay, and you will be getting the following answer: sine 2t, because k square or alpha square, alpha is s, so your k is 2 square, and 2 is there, so that is minus 3 by 2t. So that is, these are 2 which I have done. If you go to the third one is again easy, Laplace transform, this is third, see, 2s minus 5 over s square, and that is equal to L inverse of 2s over s square minus Laplace transform of 5 over s square. This is 3. 5 over s square, and that is 2 over 1s is cancelled, and you get L inverse 2 1 over s minus L inverse 5 is here 1 over s square. Okay, and answer is the following: it is equal to 2 minus 5t. Now see how I got it. Look at the table. 1 over s when it is 1 over alpha when it is Laplace of 1, so you will be having 1 for this. So 2 into 1 is 1. Minus 5 Laplace of 1 over how much? Inverse of 1 over s square, and see what I should do here. S is this one alpha, so alpha is s square, mean n is 1, and it is 1 over 1 plus 1, so it is 1 over s square, and this is minus 5 t. This is 1 over s square is t because n is 1, and that is t. Okay, and similarly, with the help of this, your s is alpha raised to the power k, and k in your case is how much? K. So what will be your answer? You can guess it, k, what you will get out of it. Okay, so try to do it on your own, and I think this is sufficient for today. Please complete these questions, and they keep them with you. They will help you towards your study, towards the examination. Thank you.